We bring it down, and what we're going to do is we're going to set the radius to this guy, for this guy, to 4, and we're going to leave the height at 20. Radius just sets the thickness of the bolt. So we'll go ahead and put him down there. Then we go back up to our primitives menu and grab a torus. For the torus, the major radius needs to be the same as the radius for the cylinder. So in this case it's going to be 4. And then the minor radius, which is used to control the thickness of the threads, we're going to set that to 0.5, which is a value that I've used pretty frequently when making these for different things. So once we have all that set, we're going to place this torus on top of the cylinder, centered on top of the cylinder. So once we put that down, we'll go ahead and select the torus and press D, and that will drop it down to the XY plane, setting its Z coordinate to 0. So now that we have that in place, we need to draw a polyline, and we're going to draw this line to just cut the torus in half. So we're going to draw it exactly through the center. We've got our line. Now what we want to do is we want to use that line to split the torus in half. So we're going to go up to the modify menu and scroll over to split solid. We are going to select the torus and then come up here, change the selection to split entity, and we're going to select that line we just drew. Now you can see what it's going to do is it's going to split that torus in half based on where that line is. So we're going to hit enter, and there we go. We can get rid of that line. And if you scroll in, you can see that it is actually split in half. So now what we're going to do is we're going to move these halves of the torus around a little bit. So we're going to select the first half, select move, then you're going to grab the angle knob, the X angle knob, and you're going to set that to be typically a relatively small number. In this case we're going to choose 6, so it's going to slant it 6 degrees, and then we're going to select the other half of the torus. We're going to click move. We're going to use the same X axis or X angle knob, and we're going to put -6. Whatever number you put in, it needs to be the negative of whatever you set the other to be. So you hit enter, and so now you can see they're a little out of line. So we select both halves of the torus. We're just going to make some copies. So you Control Z, Control V, or Command C, Command V if you're on a Mac like I am, and we're going to make some copies. So we make 1 copy, 2 copies, 3, and I know this would probably be faster with something like the pattern tool up here, this guy, but I've kind of committed to doing it this way, so that's what we're going to go with. So alright, so I think one more set will do us. There we go. So that should be enough. Now that we have all of the pieces of the thread that we're going to need, we start putting the thread together. So what we're going to do is we're going to use the snap tool to start snapping this thread together. So you click the snap tool, and we're going to click the face of this guy, and we're going to try to position our camera better. Ooh, what's happening? Okay, that was rough. Let's see if we can't get a better vantage point here. There we go. And we're going to select the other face that it got out of line with. So we do that, and you can see, let's go back home. You can see over here that the threads are going up like you would expect threads on a bolt to go. So now we are going to just continue snapping. So what you're going to want to do is you're going to want to use the snap tool. You're going to click whatever face of one of these copies would match up with the face not attached to any threading. So you click here, and then you click here. There you go. And you just keep doing that, just like this. I'll do a few pieces, but this is rather tedious, and there's probably a faster way to do it. But if there is, I am not thinking of it right now, so we're just going to go with this. Anyway, so just keep on snapping, and I think by this time everybody kind of gets the point, so I'll probably speed this up or cut it out altogether so that it does not bore you, and we'll come back when the threading has run up all the way to the top of the bolt. So we will be right back. Okay, so we're back, and we're just about at the top. I just wanted to come back to kind of explain. I like to put the threading all the way up past the top of the cylinder. So, and that's pretty much just to make the threading come up and run into the head of the bolt. It's really kind of a preference. You don't have to do it, but I do. And if I were advising someone else, I would probably tell them to do it as well if that's what they needed. So now, wow, we had just enough threading. So now, one thing I would like to do is just snap one more piece to the bottom right here. There we go. And I guess we can go ahead and delete him. So now what we need to do is we need to create a polygon. So we'll come over here, go to polygon. For sides, we're going to choose 6, so that if you make this a size that can fit into a particular size socket, it'll work out for you. We're going to put the radius of the polygon at 8. Just kind of arbitrarily picking that. Also do believe it is a standard socket size. I can't remember which one, but I think it will fit. Anyway, so we're going to go ahead and place him down. Okay, now that we have our polygon, what we're going to do is create a copy of this. So we're going to make this copy. We're going to drag him over here. Okay, now what I'm going to do is I'm actually going to select these bottom pieces of threading, and I'm just gonna make them individual pieces, and I'm actually gonna delete the bottom 2 pieces on this guy, and then I'm gonna select the whole thing. I'm going to scale it. So this bolt that we've copied and taken the bottom threads off of is actually going to be the piece that we use to make the nut. Since my goal was to 3D print these, making it the exact same size as the actual bolt is going to be never worked. It might be inaccuracies of the printer. That's actually exactly what it is, I'm pretty sure. But either way, you're going to want to scale the object as a whole to be larger. So you hit scale, and this is just sheer experience from experimenting with this, but I've found that 1.09 as the scale factor works really well. Not too tight, not too loose. If it comes out kind of loose, you can actually knock that up to 1.1 and it gets a fair bit tighter. I can't tighten them by hand. I have to get a tool. So if you have used the appropriate size polygon to get something that fits into a socket. It's actually a lot easier to work those together. My preference is 1.9. So there we go. We've scaled him to be larger. Now we want to go ahead and extrude the piece for our nut. The nut is going to have a height of 8. That's again kind of arbitrary. That's the size I typically make them. They just have a good size to them, but again, that's completely subjective. You can make it any size you want. You just want it to be thick enough to be kind of durable. So now we are going to merge this into one object so that we don't only move some of it. Okay, I messed that up. Let's try that one more time. Gonna merge him. Yeah. Okay, third time's the charm. So now we're gonna merge this together. Let's go ahead and select all the pieces. There we go. Perfect. So now, the reason I removed the bottom threading off of these is so that once I merge it all together and I click snap and snap the bottom of this thread to the nut, it would be centered on the nut. And I've actually just started doing that, because if you run the threading all the way down to the bottom and combine them all into one object, it will not be exactly centered on the nut. So that was, well, it wasn't really even an issue. It just was more of a cosmetic thing that bothered me. So now we're going to take the nut and we're just going to slide him completely through the bolt. And the only thing you want to make sure of when making the nut is that the threading runs all the way through the nut polygon. You want to make sure it runs all the way through. You don't want to stop at some of this section where we removed threading. You want there to be threading barreled all the way through the nut. So we've moved him. We're going to do a subtract operation up here in the combine menu. So we got to subtract. First you click the nut, then you click the bolt thread, and there you go. There is our nut. So now we really only have two more things to do. We have to make the bolt head, and we'll go ahead and make that a polygon. We'll raise it out of our existing polygon sketch with a size of 4. Then we'll use the snap tool to snap him onto the top of that cylinder. And then what we'll do is we'll make one more. Let's readjust our camera. So then we will extrude one more arbitrarily sized piece. So now what we're going to do instead is merge this all into one piece. There we go. So now that's all one solid piece. We're going to snap him to the bottom, and then what we're going to do, take the subtract tool again from the combine menu. We're going to subtract the whole bolt from this polygon, and what that's going to do is it's going to make our threads run all the way flush all the way down to the bottom. So there we go. We've got our nut, we've got our bolt, and what I'll actually do is I'll go ahead and send these over to my 3D printer. So what I'll do is I'll go ahead and shoot a real quick, taking them off the bed, screwing them together, taking them off. If you're going to 3D print this, the only real consideration, and this is probably obvious, but you want to print this so that the top of the bolt is actually on the bed of the printer. Pull in one of these right here. Just one more. There we go. So you just want that to be like that. And then, in case anyone's interested, to export this out, we'll just go export to STL. We'll hit OK. Then you navigate to wherever you put your files, and you can see I kind of already did this before, but we'll go ahead and overwrite this file called whole thing because it's going to export an STL of both the nut and the bolt. So we will go ahead and write that out. We'll delete these files to make sure that we're using the ones that we just created. You open the STL. Mine opens in Mesh Mixer. That's the only thing I really use to do this, so that's the only one. I'm not sure how to do this in other programs, but you can see in the object browser we have two objects. We have the bolt, we have the nut. Whichever one of these is highlighted over here, if you click export, it's going to export that object singularly. So if we go back to our folder and we can type in nut, so now we actually have the STL for the nut in its own file. We can go to the bolt, do the same thing, highlight the bolt, and we'll call this bolt. We'll save it, and there we go. We have our STL files that we can run to the 3D printer. So I will go ahead and set those to print, and we'll show you how it goes. So here's our nut and bolt off the 3D printer. I cleaned them up just a little bit. There was some strings inside this nut, but they were easy enough just to scrape out. And honestly, you don't even need to. You can just put the nut and bolt together and it will remove any kind of burrs or anything like that inside the part. So I also made and printed these because these things can actually be pretty hard to put together by hand. I can make another video if there's interest on how I made this. It's actually super simple, but I just wanted them to help me put them together and take them apart, because the first time you put these together, they're likely to be kind of difficult. Well, not even really getting it started per se, but once you get a bit down the shaft of the bolt, it can be pretty difficult. So I just made these to help out. And you can see, here we go. If I can get that lined up, there we go. So we can just turn this guy underneath. You can see the bolt rising out of the hole in the top of the wrench that I made. And I actually made it so that they weren't just a polygon all the way through, so that it would catch it and I could do this easily without having to worry about the bolt slipping all the way through the wrench. So anyway, there really isn't a whole lot of resistance when using these, but if I was doing this by hand, I imagine it would be pretty tight. So here we are completely together. It's all the way together, and you're probably not going to be able you're probably not going to be able to take that apart by hand. I just tried pretty hard. I'm going to try again. Yeah, they're together pretty good. So we can use the tool and lefty loosey. Let's see, left. Nope, that's right, left. Nope, oops. Let's try that. There we go. Got to break it loose because I tightened it up a good bit. But so there you go. Nut and bolt, it works. I've used them to hang things that I've also 3D printed, and I gotta say, they're tough. When they're even partially tightened down with the scaling, we had set it 1.09 on the clearance inside the nut. There's no play. Now you can do it at this point by hand, but there's no wiggle. You can't. You can't just pull that apart or anything. It is really together. So yeah, I've found a lot of uses for these, and for these. These are really cool and easy to make. Like I said, if there's any interest, let me know. I'll make a video on how I made it. It's actually very easy. If you can't figure it out, just by looking at them, I would make a video for it. Anyway, hope you guys enjoyed it, and I hope it's helpful. Thank you.